Happy morning to all. Happy morning. Okay. Yesterday we learned about that coordination compound lesson. The nomenclature of coordination compound. The nomenclature. How can you say the name of the complex? It's a very important lesson. How can you say the name of the complex? And we learned that what are the rules? Which are the rules we have? We should be follow the name of the complex. Which are the rules? First, you should be find out the simple cation. Next, only goes to the complex anion. Am I right? I said that the rules. What are the rules? If you learn means, you can be find out easily. What's the name of the complex? Okay, simple cation. Next goes to the ligand. What is about the ligand? Ligand is a group of an atom. It should be attached to the central metal atom. Okay, ligand. The next one is, sometimes if you have two or more ligands means, you should be give the priority as per the alphabetical order. Okay. And next one, after finishing the ligand, give priority to the central metal atom. Central metal atom. Okay, after finishing the central metal atom, you should be find out the oxidation state of the central metal atom. Oxidation state. That also we learn many times. We learn how to find out the oxidation state. Next, after finishing the oxidation state, you give the Roman letter number to that particular metal, central metal atom. Then finally it goes to outside the coordination entity having some ions. That it should be right. If you have number of examples are there, we should be do all the example. Okay, due to the insufficient time, we are going somewhat fast. Okay, so try to finish all the example. I will give the assignment also. Try to complete the assignment. Okay, please all of you take the book. We can be write the name of the complex coordination compound as per the IUPAC rule. Okay, please all of you open the notebook. Okay, we have the last video. We learn about what are the rules. What are the rules for the nomenclature of coordination compound? Today we are going to discuss about what are the examples. How can you say the naming of coordination compound by using IUPAC? Here, I am taking one of the examples, K4 FeCN6. This is one of the example. First one example, one of the coordination compound. How we are going to say the IUPAC name for this compounds. Okay, the rules and everything we are discussed yesterday class. Okay, today we are discussing about only the name. Okay, first you should be say this compound. Which one is a simple cation and next one is a complex anion, like that. Okay, that means this is a simple cation. Okay, 4K plus. Okay, plus FeCN6 4 minus. Okay, so the first one is what? The first one is simple cation. Simple cation. Okay. So the cation. What is the cation? Here the cation is K plus. So K plus means we can be say potassium. Okay. Potassium. The first one is here. We give the number here. First one is say the potassium. Second one is here. Ligand. Ligand means Cn. The next one is central metal ion. Okay, this is the number. Okay, the first one goes to where? The cation, simple cation. Second one you should be say the ligand. The third one is the central metal ion. Okay, okay. Anyhow, first we are going to say potassium. Okay, that's a simple cation. Next, potassium. Next one, Cn. that means a Ligand. Ligand is Cl minus. Okay, Ligand. Here, how much number of Ligand is there? 6. So we are going to say hexa. Okay, hexa. Potassium hexa. Cn group is ambidentate ligand. We already I told you that cyanido. Okay. Cyanido. This is an ambidentate ligand. Here, the carbon is attached to the central metal ion. Okay, which one is attached to the central metal ion? Carbon. So we can use it as K. K means kappa. Okay, kappa C. Okay, K means what? Kappa C. Here. And here, this is the coordination compound. This is the coordination entity. Here having the third one is, that is a, what is the third one? Third one is a ferrate, am I right? Ion, one of the ion, that is a ferrate. Why we are saying the ferrate means, this coordination entity having the negative charge. Negative charge ends with 8, ferrate. And the oxidation state for EF is Roman letter 2. Okay. This is the name of the complex. Can you write? Here, how the oxidation state we should be find out. In the previous video I told you how to find out the oxidation state. Let us we can discuss today also how we are going to find out the oxidation state of F is, that is Roman letter 2. That means we can be right. Here we should be find out this X. Okay. So X plus we should be take the ligand, that is cyano group. Cyano means which the Cn means value is -1. So how much -1 is here? 6. So you should be right. 6 into -1 equal to this particular complex having charge. What is the charge? That is a -4. Okay. What is the charge? -4. Can you understand? You should be find out this. What is the oxidation state for Fe? For that we are going to take the coordination entity. Okay. Here, this one we are going to calculate it. F is taken as X plus ligand 6 having 6 into -1 is equal to -4 means this charge. So can you say what is the answer? X is equal to -4. 6 into -1. This is -6. Next go to +6. Okay. So X is equal to +2. So the oxidation state is what? +2. Can you write? So as per the IUPAC name, what is the name of this complex? Potassium. Okay. It's a counter ion. Okay. The first number priority goes to potassium. Next about the ligand. Next one is the central metal ion. Okay. First one goes to potassium. Second one ligand. Third one central metal ion. So the name of the compound is, the name of the complex is potassium hexacyanide. K means kappa. Here carbon is attached to this Fe. So we are writing Kc. Okay. Fe, that is ion. It has the negative charge. So we are using ferrate. The oxidation state for Fe is 2. So we are using Roman letter 2. That's the first name. Clear? What is about the next one? As per your textbook, what's the next one? CONH3 5 times Cl2. Next complex is CO NH3 5 times 4 times, sorry, NH3 4 times Cl2. Cl. CO NH3 4 times Cl2 Cl. Here, this is a what complex? This is the cationic complex or anionic complex. Can you see? 3. Okay, so you should be say the charge. Okay, everything you should be say. That is CO NH3 4 times Cl2 plus Cl minus. So it's a complex, anionic or cationic. Yesterday we discussed that one. As per this rule, it is a cationic complex, cation complex. Okay, because the complex having coordination entity having plus charge, so we are saying cationic complex. This is the symbol anion, symbol anion. Symbol anion. Then here give the number. How can you give the number? The first priority goes to here having ligands. What is about the ligands? There is 2 ligands having. First gives to NH3, second gives to chlorine, third gives to cobalt, fourth gives to chlorine. Okay, chloride. That means these 2 are the ligand. Ligand means as per the alphabetic order, we are ammonia. We are writing amine. Amine. I told you that ammonia can be written as amine. How much amine is there? 4 amine. So the name of the complex is tetraamine. Tetraamine. How much chlorine is there? This is also ligand. Okay. 2. So we are using dichloro. Okay. Dichlorido. Dichlorido. Cobalt. Okay, cobalt, the oxidation state for cobalt is 3. Okay, that also we can be find out 3. And here we should be write chloride here. So first we should be say the name, what ligand name. Here having 2 ligand as per the alphabetical order. First give to NH3. That means tetraamine, dichloro, dichlorido, cobalt. The oxidation state for cobalt is 3. Okay, cobalt 3, chloride. Can you write? If you are learning the previous video, we are watching the previous video, then only can we say the name. Because the reason, there have only the rules. How can we say, as per the IUPAC name, how can we say the name of the complex? Okay. As per the rules I am saying, first goes to, this is the cationic complex. Okay, this is a symbol anion. The start of the here, the ligand. First priority goes to ligand. Second ligand. Third center metal ion. Next one, ions. Okay. This is about the this complex, and how can you find out the coordination? Here once again I am explaining you how much ligand is there. 4 ligand, that is 4 amine. 4 amine we can use tetraamine here. Chlorine, how much chlorine is there? 2 chlorine. So chlorine should be right. Chlorido, how much chlorine is there? 2. So we are using dichlorido. Cobalt, the oxidation state for cobalt is plus 3. Okay, 3 oxidation state, plus 3 oxidation state. And about one of the chlorine is outside present. If you are using chloride, then find out the oxidation state for cobalt. How can you find out the oxidation state? That is, we can be write the equation. First you take this complex. Okay, take the complex X, cobalt we don't know, so we are taking X plus ammonia. It is a neutral ligand, so we are using 0. Okay, how much is 0? 4 into 0. So 4 into 0 plus next one. I told you about the chlorine. It's having the one charge -1. How much chlorine is there? 2. So we are using 2 into -1 equal to what is the charge? Entire charge. That is the plus 1. Okay, entire charge is what? Plus 1. Plus 1 is the charge. So anyhow, we should be find out the answer. X plus 4 into 0 is 0. 0. 2 into -1 is equal to X minus 2 equal to plus 1. x plus 3. X is equal to plus 3. This is the oxidation state for cobalt. Like this method we can be right. Anyhow, everything is over. That is the first one is about the Ligon. We are seeing tetramine, correct? Tetramine. Second goes to dichloridor. Dichloridor is also correct. Next one is what? Cobalt. Cobalt is also correct. The oxidation state of cobalt is plus 3 is also correct. Okay. Next having chloride. Chloride. This is the IUPAC. Here. Have it out. Next one. Examples. The third example. Important question. It's the third example of coordination compound. We are using the Cr metal. Cr means chromium metal. Which metal we are using? Chromium metal. CrEn thrice CrF6. Okay, this is one of the complex. You should be say that here having two complex. So one complex with coordination, two coordination entities there. Okay, you should be say that two. Okay, the first one is goes to. This is imagine this is a maybe it is a cationic complex. It may be an anionic complex. We can be write like that. CrEn thrice. CrEn thrice here. Then we write the coordination number of chromium is plus 3 plus. Here CrF6 3 minus. Okay. First we are taking first one. What is the first one? What is about the cation complex? First we have a cation complex. That is CrEn thrice C plus 3 plus. Okay. About the ligand. What is about the ligand? Ligand. Yesterday I told you about the En. What is about that En? Ethylene diamine. Ethylene diamine. Okay. Don't forget that. Ethylene En means what? Ethylene diamine. Ethylene diamine. En means ethylene diamine. It is also bidentate ligand. Okay, bidentate ligand. Ethylene diamine is also a bi means two. Bidentate ligand. Okay. So we are using for En. We can be used as. We cannot write ethylene diamine. We cannot write that ethylene diamine. For that, ligand is how much ligand is there? En, how much ligand? It's a 2 ligand. So we have to write writing tris, Tris, tris. Okay, it is ligand itself containing a great prefix. Di used as an alternate prefix. Okay, so it can be used as what? 3 ligand we having 3 ligand. So we are using what? Tris, Tris. What's the name of tris? Tris means 3. Okay. Tris. And also, we can be written as, for ethylene diamine, we can be written as ethane 1, 2 diamine. Okay. Ethane 1, 2 diamine. Okay, diamine. Clear? Then next about central metal ion. This is central metal ion. It's a chromium. It's an anionic complex. How can you find out the oxidation state for this complex? Oxidation state. Chromium is taken as X. Ethylene diamine, the number is 0. So X plus 3 into 0 equal to 3 plus. Otherwise we can write plus 3. X is equal to plus 3. This is the oxidation state for chromium. Okay. So how can we say the name? Can you say the name? First one complex, can you say the name? We can be written as En, we should be write tris. Inside the bracket you should be write ethane 1, 2 diamine. What's the next one? Chromium. What is the oxidation state of chromium? Plus 3. So we can be written as the name tris ethane diamine. Next one is what? Which element is there? Which metal is there? Chromium. The oxidation state of chromium is 3. So we are using Roman letter 3. And next one, okay, next one is, next complex, this is an anionic complex. Which complex? Anionic complex, because I have minus charge. So start with the ligand first. How much fluorine is there? 6 fluorine. So 6 fluorine should be right hexacyanide. Hexacyanide. Here you should be use the 8 because the charge is negative. So chromate. The chromate oxidation state is 3. Okay. This is the name of the complex. Okay. The next one is having a lot of example. How can you say the example? More example. This is a very important for the one-word question. So try to work out at least 5. Okay. Due to the insufficient time, we are learning some of them only. Okay, remaining if you have any doubt, we can discuss later. Okay. Anyhow, the first one is Ag NH3 twice Cl. This is one of the complex. Next, the more example, one of the complex Ag NH3 twice Cl. Example, how can we say the name of this complex? Okay, I told you that before the coordination entity, there is no metal is there. Okay, before the coordination entity. Okay, before the coordination entity, there is no metal is there. So we are giving the first priority goes to ligand. First priority goes to where? Ligand. Next one goes to the central metal ion. The third is the chloride ion. Okay. Then how can you say the name? That ammonia can be written as amine. Okay, amine. How much ammonia is there? 2 ammonia. So we are using diamine. Diamine. Here silver. Okay, so metal is what? Silver. The oxidation state of silver is 1. Okay, so we are using 1. Roman letter 1. Here chloride. Okay, this is the name of the complex. Okay, suppose chlorine is act as a ligand means we should be say chlorido, but it is not a ligand. Okay, it is present on the outside of the coordination entity. Okay, outside the coordination entity. So we are saying chloride. Clear? Can you say the name? What's the name? Can you say? Diamine, silver 1 chloride. Diamine, silver 1 chloride. Clear? Okay, next one example. CO, cobalt. En means, now I told you that it is ethylene diamine. Okay, so it should be used what? 2 means bis, 3 means tris. Okay, then CO, En twice, Cl2, Cl. Here, try to understand that this is a ambidentate ligand. Okay, ambidentate ligand. Ethylene diamine can be written as ethane 1, 2 diamine. Okay, ethane 1, 2 diamine. Okay, here having 2 ligand. This also ligand, Cl2 also ligand. En also ligand. Am I right? As per the alphabetical, first priority goes to chlorido. Okay? Ethylene, E goes to second, chlorine, C goes to first one. Okay. So, we can be say dichlorido. Ethylene diamine can be written as, if you are having 2 means bis, 3 means tris. So, 2, so we are using bis, dichlorido. Ethylene diamine we are writing what? Bis. Inside the bracket we should be write ethane 1,2 diamine. Ethane 1,2 diamine. Okay. After that what? After that cobalt. Already told you the oxidation state of cobalt is what? 3. Okay. Cobalt 3. Here having chloride. Can you say the name? First priority goes to chlorine. This is both of them are ligand. First goes to chlorine. Second, ethylene diamine. Third, central metal ion. Fourth. Okay. As per the number we should be saying. Okay. The next one. The transition element also we learned, that one is the next one. Cu NH3 4 times SO4. Cu NH3 4 times. Cu NH3 4 times SO4. This is one of the complex. Yeah? This is one of the complex. How can we see the numbers? Before the coordination entity, there is no metal is there. So first priority goes to ligand. Ligand the first priority. After the ligand, give to the metal, central metal ion. Central metal atom. Next ion 3. Can you see the name? Ammonia. Ammonia can be written as amine. Okay. There is 4 ammonia is there. 1 means mono, 2 means di, 3 means tri, and 4 means tetra. Okay, tetra. Here, tetraamine. Here, tetraamine. Who is the central metal atom here? Copper. Copper. What is the oxidation state of copper here? Oxidation state, Roman letter 2. Sulfate. The substitute will find out, no problem. Copper is you are taking X plus ammonia 4 into ammonia is 0, neutral ligand, plus this is what? Here the sulfate is what? Is equal to, we are writing is equal to -2. Okay. So X is equal to +2. Can you write? This is the oxidation state. Next one is, as per our textbook, what's the next one? CO3. It's a carbonate. NH3 4 times Cl. Okay. Here, the both two are the ligands. This is the cobalt is the central metal ion and chlorine Cl is the chlorine. Am I right? The first one NH3. As per the alphabetical order, which one is the which ligand can be written first? That means A, ammonia can be written as amine, and carbonate we can be written as carbonato. Carbonato. Which one is the first priority? Carbonato or amine? Amine. So we are giving number 1. Number 2, carbonato. Number 3, central metal atom, that is a cobalt. Number 4, chloride. Okay. How can you say the name? Here 4 ammonia is there, so here ammonia can be written as amine. How much ammonia is there? 4 ammonia. Tetraamine. Okay. Here having single carbonate, so we are writing carbonato. Okay, carbonato. Cobalt. The oxidative state of cobalt is 3. Cobalt 3 chloride. Have any doubt? Oh. Next one is as per the textbook, the next one is the 5th one. Next one is the 5th one. Cr. The chromium metal Cr, NH3 thrice H2O thrice Cl3. Okay? Here Cr means one of the chromium metal, NH3 ammonia, 3 ammonia and 3 water molecules, and about chloride is there. So, how can you give the priority? Both the two ligands. Before the coordination entity, there is no metal is there. So, we are giving the priority to ligand. Here having 2 ligand is there. How much ligand is there? 2 ligand. One is amine and one is an aqua. Water can be written as aqua. Am I right? Aqua. And yesterday I told you that water is a neutral ligand, it can be written as aqua. Ammonia is also neutral ligand, it can be written as amine. Clear? So, how can you write the namings? How much? As per the alphabetic order, this is the first one, aqua is the second one, and the central metal atom is the third one, and the chloride is the fourth one. So, how can you say the name? 3 ammonia is there, 1 means mono, 2 means di, 3 means tri, am I right? So triamine. Here are 3 water molecules. Water can be written as aqua. So triaqua. Chromium. What is the oxidation state of chromium? 3. Here chloride. Have it out? Okay. Next one is the 6th one. How can we say the name? K3. Fe, CN5, NO. Okay. Here, before the coordination entity, one of the metal is there. Am I right? The previous example you just check it there. Before the coordination entity, there is any metal is there? No. But here, before the coordination entity, there have only metal is there. So give the first priority goes to potassium. Okay, potassium. Here, cyano. Here, this cyano, we are using cyanide. Okay, cyanide. How much cyanide is there? 5. 5 means pentacyanide. Clear? Pentacyanide. NO can be written as nitrosyl. Okay, nitrosyl. And this complex is about. This is a plus charge and this is about the minus charge. So, ferrate, minus charge means you should be right, ferrate. The oxidation state of Fe is plus 2, so you are using Roman letter 2. Roman letter 2. Okay? So shall we write down? The first priority goes to potassium, second goes to cyanide, third goes to nitrosyl, fourth goes to ferrate. Okay? Ferrate 2. Okay, can you write the name? Potassium. Potassium, how much cyanide is there? 5 cyanide. So you can write down as penta cyanide. Here, this carbon is attached to its ambidextrous ligand. Am I right? I told you that Cn is an ambidextrous ligand. Carbon is attached to Fe. So you can write as kappa, K, Kc. Okay, Kc. And what is the next one? Nitrosyl, Nitrosyl. Nitrosyl, Fe, ferrate, because it is a negative charge, negative complex, that is an anionic complex. So ferrate, ferrate 2, ends with 8. Okay, this is about the complex name. The next one is one by one you should be learn. Okay, at least you should be write and do it. Have any doubt, means call me. Okay. This is for the one word question. Sometimes it may be asked for the one mark question. Next question. Seventh one. Next one is the seventh one. Na2. Okay, Na2, Ni, EDTA. Okay, EDTA. What is about the EDTA? Ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid. Okay, this is called what? EDTA. For this one, we can written as per the IUPAC's name, we can written as 2, 2 single dash, 2 double dash, 2 triple dash, ethane, 1, 2 diethyl, dinitropyl, tetraacetate, acetato. As per the, I think that the page number, please refer the page number. The page number 137. This goes to page number 137. 137, in the tabular column, having ethylene diamine tetraacetic acid. Okay, EDTA, ethyl diamine tetraacetate. What is the IUPAC name of that compound? 2 single dash, 2 double dash, 2 triple dash, ethane, 1, 2 dinitropyl tetraacetate. Okay, that is a name. So you should be learn that one. And the first priority before the coordination entity. This is the coordination entity. They are having one of the metal, that is a sodium metal. So we are giving the first priority to sodium. Next one is a ligand. Okay, ligand name. Next goes to central metal ion. This is central metal. So how can you say the name? First one is a sodium. So you are using sodium. Next goes to ligand, EDTA. What's the name? How can you write the formula? 2, 2 single dash, 2 double dash, 2 triple dash. Clear? Then bracket you should be right. Ethane, 1, 2 diol, dinitropyl. Next one, acetato. Here nickel, the central metal atom is nickel. The nickel here, solid has a positive charge and this complex has a negative charge. So ends with nickelate, nickelate, nickelate. The oxidation state of nickel is 2. So you are writing 2. Okay? Anyhow, the remaining, at least you should be 10 more having. I think that 10 more having. You should be trying to find out that. If you have any doubt, please call me. Okay. And as about the assignment, remaining, try to write remaining any 3. That means I think that 7 over 8 or 9 or 10, 11, 12, 13, 14, 15 or 16. You should be right. Any 3. Okay. Any 3 for our assignment. Try to complete. Okay. Thank all of you. Thank you. Have a nice day.